Now let's move to the practice activity. Firstly, I will introduce to you the steps to solve Shakler's law exercise. First, identify an isobaric process. P is constant with a fixed amount of gas. Secondly, list the known and required quantities V1, V2, T1, T2. Note that you have to convert temperature to Kelvin. Thirdly, write the Shakler's law. And then, finally, substitute the values. Solve and state the final answer with correct units. Here is the example. A given mass of gas has a volume of 10 liters at a temperature of 27 Celsius degree. If this gas is heated at constant pressure to 87 Celsius degree, what will its volume be? First, let's check that is a isobaric process. Yes, because it is heated at constant pressure. So then we will list the P1, V1, T1, P2, V2, T2 of the state of this gas. Then we will apply the Shakler's law for the process from state 1 to state 2. In the state 1, V1 is equal to 10 liters, T1 is equal to 300 Kelvin, and in state 2, volume the V2 is we will find it, and the T2 is 360 Kelvin. So let's apply the Shakler's law. And then we will find the V2 is equal to 12 liters. That is the result of the volume in the state 2 of this gas. Do you understand? Okay. Now let's work individual to complete the worksheet note 2 in 7 minutes. Are you finished? Okay, let's check the results. The first question is, consider a given amount of an ideal gas. The process in which the pressure is kept constant is called a... Okay, here the pressure is kept constant. So we will choose the answer B, isobaric process. Question 2. Let P, V, and T denote respectively the pressure, volume, and absolute temperature of a given amount of an ideal gas. Which of the following formulas correctly represents Shakler's law? So, it is a very easy question. We will choose the answer B. V over T is constant. Next is question 3. In the coordinate system VOT, the isobaric constant pressure line is... Oh, it's an easy question again. Yes, we will choose the answer A. A straight line passing through the origin O. Now let's move to the question 4. It's a little bit, it's the same of the example that I have teach you. When the temperature of a given amount of gas is increased from 27 Celsius degree to 67 Celsius degrees while the pressure is kept constant, the volume increases by 1 liter. The volume of the gas at 27 Celsius degrees is... Okay, the answer of this question is D. Here is the solution guide. As state 1, V1 is the one that we don't know. So, and T1 is 300 Kelvin. And in state 2, V2 is equal to V1 plus 1 liters. And T2 is 340 Kelvin. So let's apply Shackler's law for the process from state 1 to state 2. And then we can find V1 is equal to 7.5 liters. And the last question is, a quantity of gas at a temperature of 17 Celsius degree is contained in a vertical cylinder with cross-sectional areas S. Initially, the piston is at a distance h0 equal to 40 cm from the bottom of the cylinder. When the gas in the cylinder is heated to 61 Celsius degree, the piston rises by approximately, it's a little bit harder. And in this question, we will choose the answer D. Here is the solution guide of this question 5. Remember that the volume of the gas in the cylinder is V equal to S times H. S is the cross-sectional area and H is the height or the distance. So in the stage 1, V1 is equal to S times H0. T1 is 290 Kelvin. And in state 2, the V2 is S times H0 plus delta H. Delta H is the distance the cylinder move. And T2 is 334 Kelvin. So apply Shackler's law for this process, and we can find the delta H is equal to is approximate to 0.06 meters, that is 6 centimeters. Do you understand all of this question? Okay. This is the end of our lesson today. Thanks for your listening and attention.